Hey everyone, welcome back to Console. In this episode, it's actually going to be broken up into three different parts because we're going to be writing a compiler for a basic style programming language in Python. It's going to be broken up into three parts because, as the blog author states, he views compilers as three different pieces working together, right? So there's a Lexer, there's a parser, and an emitter, and in this video we'll be going over the Lexer. So without further ado, let's jump right in. So this is the blog post written by Austin. He's a professor in Tennessee, so I should be calling him Dr. Henley. Here I'm just checking out his Twitter and his GitHub page and all this stuff. The blog post that we're going to be going through is actually on GitHub, similar to the previous blog post. I'm going to be writing all the code instead, though, just to illustrate and for my own learning, all that other stuff. But the general idea here is that we're going to take a basic kind of language and we're going to write a compiler for it in Python. So I've mentioned in previous videos I'd written a compiler in college, but we used like the professional compiler Lexers and things like that. In this particular blog post, we're going to write the Lexer. So actually the series is a three-part series, and he breaks it down in the blog post. Like, in his mind, a compiler's three different stages, and so the blog post is going to go through each of those stages for each part. So this is part one that we're going to be going through. It'll be the first video, and then I'll do another video and finally a third video. And in this one, we're just writing the Lexer. And what the Lexer does is it parses through the input of the source code and creates tokens out of the source code. So in this case, you can see here like he's got a fake toy example of this basic language that we're going to be writing a compiler for. It's saying print how many Fibonacci numbers do you want is a string, and then the input is nums, right? So I don't know anything about the programming language, but I'm guessing, right, the print statement is a keyword in the basic programming language. It will print out this string, and then input will actually take input from the standard input, right, and so on and so on. But in order to write the language, in order to compile the language, in order to like make the computer do things in particular orders, we have to first understand the language, and the first part of that is parsing the language and creating these, like I said, tokens out of the language itself. So let's get started. So right here is where he's talking about the three parts of a compiler. You got the Lexer, the parser, and the emitter. And like I said, in this particular blog post, we'll be going over the Lexer. In the next one, we'll be going over the parser. And in the final one, we'll be going through the emitter, and we'll have an actual compiled language at that point. Right here, he kind of gives you an overview of what a Lexer is. As I said earlier in the video, we're just basically reading through the characters one by one in the source code file and detecting whether the character is part of a keyword, whether it's part of a variable, whether it's just an operator, whether it's a number, right? All these things need to be taken into consideration. So we're going to write that part of the compiler in this blog post. So what Dr. Henley does here is he lays out the Lexer class, basically. He doesn't implement any of the methods at the beginning. He just says, these are the methods that I think we're going to need to have to write a Lexer. I think he's being biased, right? Because he's probably written the Lexer beforehand. But we need to start somewhere, and so that's what we're going to do here is we're just going to lay out all these methods, and then we'll implement them one by one and test them as we go along. So the first thing we need to implement is the constructor. Here we're passing in the input, right? This will basically be the source code here. We're passing in the input. We're going to maintain the current character, the current position, and then we're going to iterate to the next character as well after reading in the input into the constructor. So those are the three variables generally we're going to be using in this class: the source code itself, the current character, and the current position. Okay, so now we need to implement next character, right? We called that right at the very end of the constructor. At this point, we're just going to implement it. It's pretty standard, right? We're going to increase the current position. We're going to check whether or not we've hit the end of the source code array, basically. And if we have, we're going to return a end of file character. Otherwise, we're going to increment the next character in the source code array. So the next thing we're going to implement is peek. We've already written next character, right? The next thing we need to do is peek, and we're going to need this because oftentimes it's the case that in order to determine what type of token this is, you need to know what the next token is, right? Like in the case of not equals or greater than or equal to, right? In those cases, you need to know whether this is just greater than or if it's greater than and equal to before you create the token. And so that's why you need this peek operator in your Lexer. So we've written two of the most basic functionalities of our Lexer here, and all I've done is I've just followed his example. I've written a little test, and you can see it doesn't work, and that's because I copy pasted some of his method definitions, and he was using spaces, I was using tabs. But the current implementation of what we got here actually does work, and it does return what he's printing out here as well, right? And you can see all we're doing in this case is we're just reading through the characters one by one, continually calling next character, and then we're printing the current character until peek, which, like I said, reads one step ahead, returns the end of file character. So we can see here that our Lexer is in fact Lexing. At least it's doing the beginning of Lexing. So at this point in the post, what we're going to end up doing is creating our tokens, right? So at this point, he's going to have us read like the most basic tokens and create the most basic tokens, and those are just like the standard operations. And these particular operations are operations with just one character in them, right? So we don't even need to peek in this point. We just need to check the current character, and if it's a plus sign, we know this is a plus token. There's nothing else that can be in the basic language. So at this point, we've basically, parsed out these single character operators, and what we're going to do next is we're going to create a token class, and that token class is just going to contain the text that we parsed, or lexed, I should say, and then an enum specifying what type of token this is, in order to make like identifying and classifying and all that, and operators like equal to and all these other things easier, right? We're going to use this enum as like a way of saying this is for example, a string, and the string contains the word, how many Fibonacci numbers do you want, for example. So now that we have our token class, we can actually return tokens from the getToken method here. And so basically what we're going to do is for each of these operators, these basic one character operators, we're going to construct a token and set it equal to that and return it at the end after we've iterated to the next character. And you're just going to keep doing that. You're just going to keep calling getToken until you have all of the tokens for the source code, at which point in part 2, presumably I haven't looked at it yet, but we'll actually start doing something with these tokens. So the tokens are like super important, right? They're like foundational for a compiler. Constructing these tokens are super important. He points out in this blog post, like he gets it, it's kind of boring, right? We're just writing a bunch of if-else statements and just cycling through a character or a string of source code. It's not that exciting, but these are super important for what we'll be doing in future videos when we're actually creating the compiler itself. So now we have tokens, and what we're going to do is we're going to run another test, and in this case we're just going to test these basic single character operators, and what we'll end up finding is that this doesn't actually work, and that's because we're trying to parse the white space and we haven't handled the white space properly, right? So he's kind of motivating why we need to write the next method by testing this one and having it break. I won't show you the output, but generally that's what's going to happen at this particular moment in the blog post. So at this point, we need a way of surfacing errors, right? We've triggered these errors because we've got this white space and we don't know how to lex the white space yet. So he's just saying, in this case, we're going to add a little abort utility method to our lex class, and it's just going to call sys.exit. So anytime we run into any sort of error, you can almost think of this as almost like throwing an exception or something like that. And we're just going to throw this error out. In this case, we're going to say we don't know how to lex white space, and then we'll fix it right after this. So here we are writing the skip white space method. It's really nothing too crazy here, right? We're just going to check if the current character is tab or return character or a empty space, and if it is, we're just gonna skip it. One thing I actually did originally was check if it is space, right? This is a standard Python function to just check. It turns out we actually need to lex the new lines, and so you actually have to manually check the characters like this rather than using his space. So don't do the same thing I did. And so now if we call our new skip whitespace method and get token and rerun the test, we won't have abort getting called anymore, and the test should actually work. We should see plus minus asterisk slash new line, and you can see here that in fact that is the case. So now is where we actually use that peek method that we had created previously, right? Here's a case where we need to know whether this is variable assignment or if it's variable equality, right? So in this case, if it's a single equal sign, we know that's variable assignment. If it's a doubles equal sign, we know it's equality. In this case, we need to use peek in order to get that one character next, so we know which token that we need to create, right? And then you can see below, we did the same thing with greater than or equal to, and we do the same thing with less than or equal to. We'll also end up doing the same thing with not equals as well. So our get token has gotten pretty out of control, which I don't really particularly like, but it's working now, right? So now we, as you can see here, what we're going to do is we're going to lex some multi-line operator or multi-character operators now. So you can see greater than or equal is getting lexed, not equal to is getting lexed, as well as the single character operators as well. And you'll see what we're going to do next here is we're going to skip comments, right? So our commented lines are not going to be read by the compiler at all. We'll just skip right through them completely. One thing to note about that particular method, though, is we still do need to read in the new line character, right? As I said before, that is one character you actually need to create a token for. And now after writing the skip comment method, we just put it right below skip whitespace. So now every time we go to get a token, we'll skip through the whitespace, and we'll also skip through the comment lines. And so the next thing we're going to lex, now that we've lexed all of our operators, we've skipped comments, skipping new lines, we're actually going to read strings. So at this point we're just going to read string characters, or yeah, each character in the string, and that's delimited by the quote mark, right, and then the quote mark at the end as well. So we're going to read that first one in our case switch, and then we're going to go read through all of those, the rest of the characters inside that quote mark. One thing to note is we're going to kind of cheat a little bit to make our lives easier, and we're not going to let a bunch of like special characters into our strings. It's something you could deal with later, right? But since this is just a toy example of a language, we're not going to handle that right now. And right here we're testing the new string, right? This is a string is in our new source code, if you will, call it source code. It's not quite there yet, but you can see that it actually works. Above there you can see where I tested and I had to do a keyboard interrupt. That's because I forgot to increment, or I forgot to call next character in one aspect of that implementation. But yeah, now it's working, and it's actually lexing out the strings from our test source code. And this one we're going to lex out the digits. This is probably the most complex aspect of the Lexer, because we're going to allow floats and things like that. So you kind of need to like read the digits, check, make sure that they're digits, throw exceptions when they're not digits, and all these various different use cases. Right here you can see we're lexing out the decimal, and then at the bottom we're finally creating the number token at the very end. And here is where we're going to test the digit lexing aspect of this, right? So we're just going to take this test string, run it through our Lexer, and make sure that it's able to detect the digits, and it should, even using the decimals. And it doesn't. I forgot about this. I actually had a typo here where I use peek, P-E-A-K instead of B-E-E-K. You can see that on line 108. But eventually we run the test and everything works. And so the last thing we need to do to have our complete Lexer for the basic programming language is we need to extract or lex the identifiers. And so we're either going to lex keywords or they're going to be lexed as identifiers. So what we're going to do is we're going to read those values. We know they're not strings, right? Because they won't have the open quote and close quote. And so if there's any string that's part of the source code that doesn't have that, we know it's either an identifier or a keyword. And what we're going to do here is we're going to check our list of keywords in the token type enum, and if it is that, we're going to write this as a keyword. Otherwise we're going to just write it as an identifier. So you can see the list of keywords here is like label, go to, print, input, for example. So at this point we're going to test with something that's actually starting to look a little bit more like a programming language, right? We have if plus minus 120 foo then, right? We're going to test with this string, and these strings are starting to look a lot more like programming languages, right? So now that we have the identifier parser, right, we're at this point able to parse every single bit of input in our source code for the language that we're planning on building, and we're creating these tokens out of them. As I said, this is like super important, right, for the rest of the compiler to be able to extract the input and create these tokens. That is everything for this week's episode. Don't forget to like and subscribe. I will see you in next week's episode where we will write the parser that goes along with this Lexer. See you then.